I welcome you all. In this video lecture, we will see frequency response and impulse response of modified Duobinary system or encoder and impulse response of modified Duobinary encoder. Now we know that a modified Duobinary encoder have a delay element of 2 dB, and therefore the frequency response of this duobinary of this delay element is e raised to power minus j 2 pi f into 2 dB, and the frequency response of a delay line filter, therefore we can write it is as 1 minus e raised to power minus j 2 pi f into twice dB. Now we know that a delay line filter is followed by a Nyquist channel, and therefore a total frequency response of this modified duobinary system can be given as h of f becomes equals to h Nyquist of f into a response frequency response of delay line filter, that is 1 minus e raised to power minus j 2 pi f divided by dB. Now we can simplify this square bracket as e raised to power j 2 pi f, now here it is 2 dB, divided by dB into e raised to power minus j 2 pi f dB minus e raised to power minus j 2 pi f dB into e raised to power minus j 2 pi f into dB. Now we can take this term e raised to power minus j 2 pi dB as common, and therefore this expression becomes h Nyquist of f. Now this become e raised to power j 2 pi f dB minus e raised to power minus 2 pi f dB, now into e raised to power minus j 2 pi f dB. Now we can rewrite this square bracket term into its trigonometric identity, and therefore we can write this is as h Nyquist of f becomes equals to j 2 sine of 2 pi f dB into e raised to power minus j 2 pi f into dB. Now we know that the frequency response of h Nyquist channel can be given as the h Nyquist of f becomes equals to 1 divided by 2 b0 for minus b0 less than equals to f less than equals to b0, and it is 0 otherwise. And therefore this will implies the h of f becomes equals to 1 divided by b0 into j sine 2 pi f tb into e raised to power minus j 2 pi f tb for minus b0 less than f less than equals to b0 and 0 otherwise. Okay, now if we are going to find the frequency, that magnitude response and the phase response of this duobinary encoding scheme, so we can write that magnitude response as h of that mod of h of f, that becomes equals to 1 by b0 into sine of 2 pi f tb. Now this is for mod of f will be, sorry, it is f less than equals to a mod of b0, and similarly we can write a phase response of this system as h of f becomes equals to minus 2 pi f tb. Now if we are going to plot the magnitude spectrum and the phase spectrum of this, so magnitude spectrum we can draw like this. So this is mod of hf. So as a value of sine 0 is 0, so we get a magnitude response like this. So this is a maximum amplitude, that is 1 by b0, this is minus 1 by 2 tb, this is 1 by 2 tb plus, and this is the 0. So likewise if you are going to plot a phase response of this, so this is 1 upon 2 dB, this is minus 1 upon 2 dB, this is 0, this is nothing but a phase response. So it is like this. Now next we are going to find out the impulse response of a modified duobinary system, and it is calculated by taking an inverse Fourier transform, and it can be written as the h of t becomes equals to sine of pi t minus, sorry, sine of pi t divided by tb divided by pi t into tb minus sine of pi t minus twice b twice tb divided by tb divided by pi t minus twice b divided by tb, and we can simplify this term, that sine of pi t divided by tb divided by pi t divided by tb minus, now this becomes sine of pi t divided by tb, and this become pi in bracket t minus 2tb divided by tb. Now we can simplify this term as 2 tb square sine of pi t divided by tb divided by, now this become pi t then twice tb minus t. So this is an impulse response of a duobinary system.